Greetings. We have a question on our hands. The question goes, write the quadratic function 2y minus x squared plus 4 is equal to 0 in standard form. Draw a graph of the function and state the significant characteristics. So what we have to do initially, we have to understand what is the standard form of a quadratic function. So the standard form of a quadratic function, it is ax squared plus bx plus c. This is the standard form of a quadratic function. What does a and b represent? So a and b, of course, we say where a and b, they are representing the coefficients. Then we have also c representing the constant. And lastly, we have x, which is our variable. In other books, this is called an unknown. So this is what we are working with, the standard form of a quadratic function. So if the question requires from us to express a certain quadratic function in standard form, what we do is we take that function. In this case, it's 2y minus x squared plus 4 is equal to 0. When we take that function, we have to make y the subject of formula. So this is what we want to do. We want to make y the subject of formula. What does it mean to make y the subject of formula? Basically, we want to isolate y. And usually, it should be done on the left-hand side. So an equation is made up of two parts. We have the left-hand side. We also have the right-hand side. So this is called the left-hand side because it is on our left, and this is the right-hand side, which is on our right. So we want to isolate y on the left-hand side. That is making y the subject of formula. How do we do that? So in order for us to be able to do that, we have 2y minus x squared plus 4 is equals to 0. In mathematics, we should always have an idea of where we want to go, the result we are expecting. So in this case, we want to isolate y. That means we should transfer everything else to the other side of the equal sign. But when we are transferring terms and numbers to the other side of the equal sign, what happens is there's going to be a change of the arithmetic sign. And by arithmetic sign, we are referring to the negative sign and the positive sign. So in this case, we are left with 2y. So 2y is equal to, we transfer minus x squared to the other side of the equal sign. It becomes a positive plus x squared, which can be written like this. Then when we transfer plus 4 to the other side, it becomes a negative, becoming minus 4. So 2y is equal to x squared minus 4. But we haven't arrived yet. We want to isolate y. That means we have to remove these two. How do we do that? By dividing every term in the equation by 2. And this is a very important factor. I have to write it down. We have to divide every term by 2. And every term should be highlighted, because many of my students tend to forget that it should be every term divided by 2. So the effect of this 2 is going to cancel out on the left hand side. And of course, 2 into 2, it's 1. 2 into 4, it's 2. What we are left with here is y is equal to x squared over 2 minus 2, which we can conveniently write as y is equal to half of x squared minus 2, like this. Having done this, we have met the demands of our question, expressing that equation in standard form. But as we do that, we should now be able to know what A is, what B is, and what C is. A is equal to, B is equal to, and C is equal to. To know what A is, B is, and C is, we are taking it back to our standard form, ax squared plus bx plus c. That is our standard form. So if we look at A should be the number multiplying the x squared. The number multiplying x squared. But this number, technically, it's called a coefficient. But it's just a number multiplying x squared. So we come back to this part of our quadratic equation. What number is multiplying x squared? The number in this case is 1/2. So 1/2 is multiplying x squared. Then we look at b. B should be the number multiplying x, the coefficient of x. And since we do not have x in this part of the quadratic function, it means b is going to be equal to 0. Then lastly, c is going to be then the constant. And our constant in this case is -2. What is important in noting c? C is just a number, independent of a variable or an unknown. But c should carry its sign. You don't have to make a mistake here. C is -2. C is not equal to 2. If we go back to our question, the question says write the quadratic function 2y minus x squared plus 4 is equal to 0 in standard form. That we have done. Then it says draw a graph of the function and state the significant characteristics. So we now want to draw the graph before we state the significant characteristics. How are we going to draw the graph? I want to bring to your remembrance 2 facts which are very important. The first fact is, for a linear function, if it is a linear function, we only need 2 points, and these points are our intercepts to draw the graph. That is all we need, 2 points to draw the graph. But if we are now dealing with a quadratic function, so for a quadratic function, we need 3 points. And these 3 points, they are going to be, we have 2 roots and a turning point. I'm going to explain this so you don't have to worry to draw the graph. This is what we need. So for a linear function, 2 points are enough. They should be our intercepts. But for a quadratic function, we need 3 points. 2 of the points should be roots, and we also need a turning point. So how are we going to go about that? Our first step is going to be, we need to find the intercepts. we need to find the y-intercept and also the x-intercept. So finding the y-intercept, we need to find the y-intercept. What is the condition of the y-intercept? The y-intercept is when we have x being equated to 0. So for the y-intercept, we need x to be equal to 0. So the condition is when x is equal to 0. What is our equation, by the way? If we go back here, it is y is equal to half of x squared minus 2. So y is equal to half of x squared minus 2. We need x as 0. So we are just going to replace x with 0. Y is equal to the half of, it's now 0 replacing x squared minus 2. So y is equal to the half of 0 squared. Of course, 0 squared is equal to 0. And every number multiplied by 0 is equal to 0. So after all is done, y is equal to minus 2. Therefore, the y-intercept point, it is equal to, we have x as 0 and y as minus 2. This is what we do to find the y-intercept. If we want to find the x-intercept, how do we find the x-intercept? By the way, the x-intercept, these are our roots. And I'm going to explain in a moment what I mean. So for the x-intercept, what we do is, the condition is when y is equal to 0. And we write down our equation, y is equal to half of x squared minus 2. We need y being equal to 0. So here, replacing y with 0, 0 is equal to half of x squared minus 2. The wise thing to do here is, we firstly transfer the negative 2 to the left-hand side, or to the left, and by transferring it, after it crosses over the equal sign, it changes its signs, the arithmetic sign that is. So from minus 2 it becomes 2. So 2 is equal to half of x squared. We now want to remove this 2. It means we have to multiply by 2 here, so that 2's cancel each other. But whatever we do to the right-hand side, the same should be done to the left-hand side, so that our equations are balanced. So we have multiplied by 2 here. We have to multiply by 2 here. So 2 times 2, that is 4, is equal to 1 times x squared, it is x squared. So in this case, we have x squared. If we want to remove the squared part, we introduce the square root. But when we introduce the square root, we have to do the same both sides. So in this case, the square root of x squared is simply x, and the square root of 4 is plus or minus 2. Therefore, in this case, x is equal to plus or minus 2. What does this mean? Therefore, again, the x-intercept is going to be equal to, x is equal to minus 2 when y is 0, and x is also equal to 2 when y is 0. So we have 2 points here. These are called the roots. The roots of an equation, these are the answers we get after solving the quadratic equation. So if we solve the quadratic equation, the answers we get after, those are called the roots. So it's going to be more clearer when we consider and put it on a graph. So the next step we should take, we should actually go and draw the graph. But we should know we have calculated the y-intercept point, and we also have calculated the x-intercept points. So let us now put it down on a graph. So on this part, of course, you are going to be using your ruler. This is the y-axis line. This is the x-axis line. Then our 3 points. Firstly, we can put points here. 1, 2, 3. 1, 2, 3. Minus 1, minus 2, minus 3, minus 1, minus 2, minus 3. Just like this. So here what do? We first plot our x-intercept points. So when x is minus 2, y is going to be 0. So this is a point like this. So maybe if I put it in a different color, it will be more visible. So the point is this. Then when x is equal to 2, y is equal to 0. So this also is another point like this. After doing so, we go and find out what the y-intercept point is. So the y-intercept point, this is our turning point. So our turning point. This is the point where our curve is going to make a turn. Call it a U-turn if you want. And you are going to see it here. So it says when x is equal to 0, y is going to be equal to minus 2. So this is the point where x is equal to 0 and y is minus 2, which is this point. So what we have to do now is we have to connect our 3 points. So what we have to do now is we have to connect these 3 points starting from here. It should be a smooth curve. We do it by freehand like this, something like this. Then we put arrows here like this. Then we write the name of the curve, which is 2y minus x squared plus 4 is equal to 0. After doing this, we have fulfilled the obligations set to us by the question. So what we have to do next is we have to define the significant characteristics which we can observe from that curve. So the significant characteristics, what are they going to be? For our significant characteristics, our first point is going to be a is greater than 0. This means the graph is a smile, as you can see, or we can call it U-shaped. So a is greater than 0 simply means a is positive. And if we come back here, where we found the value of a, we see that a is equal to half, and of course 1/2 is greater than 0. So if a is greater than 0, we have an idea of what the graph is going to be like. It's going to appear like a smile. As you can see from the graph, it is also going to be U-shaped. From that, we have to put down our intercepts. So you might ask, what happens if a is less than 0, meaning that a is negative? Our graph is going to be N-shaped like this. You see? Something like this. The X and the Y. That is how our graph is going to appear if a is less than 0. So that is a very important characteristic. From that point, we should know the intercepts. So what are our intercepts? We put down all the intercepts starting with the y-intercept. So we calculated the y-intercept. Where did we do it? We did it here and we found it to be 0 minus 2. So that is what we should write down. Starting with 0 minus 2. And if we go to our x-intercepts, they are minus 2, 0 and 2, 0. So we write them down, minus 2, 0 and 2, 0, like this. So after writing our intercepts, we have to know the turning point. So I told you that the turning point is the y-intercept. So it's going to be 0 minus 2. Why are we calling this the turning point? If you look at this, right, this is the point where we have 0 minus 2, which is the y-intercept. So the y-intercept is the point the graph is going to turn. You understand? Then this one and this one, these are what are called the roots of the equation. And the roots of the equation, these are the answers we get if we had solved the quadratic equation. We were going to get answers where x is minus 2 or x is equal to 2. So that is very important. After determining the turning point, we have to know something, and these are called axes of symmetry. So axis of symmetry, we are talking about that line which divides our graph into two equal halves. And in this case, this is the line. So if we want to determine the axis of symmetry, we should know something. What we should know is this is the line which cuts across the turning point of the graph. The line which cuts across the turning point of the graph. But mathematically speaking, the axis of symmetry, x is equal to minus b over 2a. What does this mean? This means that what is the value of b? We come back here. We see that the value of b is 0 and the value of a is 1/2. So here it's going to be minus 0 over 2 multiplying a half. And of course, 2 into 2 is 1. 2 into 2 is 1. It's basically minus 0 over 1, which of course is equal to 0. So the axis of symmetry, x, should be equal to 0. That is the equation of the line representing the axis of symmetry. Then, of course, as is expected, we should know the domain of our function, and in this case, the domain x, such that x is an element of real numbers. That is the domain. And where are we getting this domain? If you look at this, you see that x is going to keep on increasing if we are to extrapolate our graph like this. And we keep on getting new values of x like this. That is why x is an element of real numbers. And real numbers, these are the naturally occurring numbers which we find and use in everyday life. You understand? But when it comes to the value of the range, we explained in our first question that the value of the range is associated with the y-axis and the value of the domain is associated with the x-axis. So what we have to do now is, for our range, it's going to be y such that y is greater than or equal to -2, and of course y thereafter becomes an element of real numbers. What just happened here? We said y such that y is greater than or equal to -2 because of this simple reason. If we come here, we can see that y cannot be less than -2 because y is starting from this point, which is the turning point. So y is beginning from -2 and it's going up and will keep on going up for eternity. That is why y is then made an element of real numbers. But before that, y should be greater than or equal to -2. That is the range in which y exists, and y is such that, of course, in set notation. So that is going to be our range. So when it comes to the range, you have to be careful because the range takes many forms. But in most cases, the domain is just going to be x such that x is an element of real numbers. Then from here, our last point is we now have to know the nature of our graph, of our curve. So the nature of our curve or graph, it's the function is decreasing for x is less than 0 and increasing for x is greater than 0. So the nature depends on x. That's the first thing to know. And secondly, we are saying the function, it is decreasing for x is what? Less than 0. So x is less than 0 when x is negative. So we are looking at this part, you understand, left of 0, right? So it's decreasing because the gradient will be decreasing. This is a downward slope. You see what I mean? And when we go to this side, where x is now greater than 0, we see an increase. From the turning point here, there will be an increase. So here we have x is actually less than 0, and we have the function decreasing. It's decreasing because it's a downward slope. And here we have x greater than 0 and we have the function increasing. So this is the nature of the graph. So I really hope that you understood what is happening here. And if you have any questions, may you please post them in the comments section. But if you want help with pure mathematics, you can contact us on these numbers: +27 7 6 1 7 3 7 1 1 6. Thank you and have a nice day.